Hello to viewers, welcome to SCALE at Chemtech 2026 in Mumbai. So today we have a very interesting guest with us, Mr.
Samyak Savagaonkar.
So please tell us about yourself. What are you doing here?
We are here to save the planet, as everybody is. But how we are adding up to this is we help industries to recover their wasted heat and convert it into electricity. Heat has been the problem of majority of industries. Major industries which emit heat in low-grade temperature sources like 80 degrees Celsius to 450 degrees Celsius. That's where we come into the picture. Because if you see the global picture of this Earth, what is happening, the global warming is happening is going on there. The temperature is rising and nobody's talking about the temperature as a main core problem for this. So that's where we come into the picture and try to help industries to recover their unused heat.
Okay, it would be helpful for all of us to understand, like, why don't we just use steam? Like, because again, we are aware of using steam in coal power plants, steam in nuclear power plants and all that. So why don't just use steam? Why use this new technology, ORC? Why?
Right. So ORC has already been there in the cycles, in the studies. People have studied this, people have explained this, people have deployed these systems. But why, if you want to compare it with the steam, then talking about the steam is developed in 3 stages: ultra, super ultra, and critical stages. So you need 450 degrees Celsius and above temperature for it to cater. Why this technology is good enough? In cases of steam, as the temperature is higher, you need to develop the turbine in such a way that the material should be sustainable with the composition of the steam, and ultimately the pressure will be higher.
Yes.
At that scale also, you need to use superalloys, you need to use titanium. That's where we can help out how the property of the fluids which we use are 20 times dense than water. So that's enable us to utilize low pressure sources also, right, ranging from 10 bar, 20 bars. And that's where we don't even need to use superalloys, and we 3D print our out turbine for that.
Okay, so if I understand this correctly, there are certain limitation with steam. Steam is great, but it requires you very high temperature
Yes.
and very high pressure.
Yes,
You
that's why
can't
the
just have
cost
very,
is also
yeah.
higher for that.
So cost becomes don't ask about it. Basically, a blank check. So it's very expensive. Now, what you are utilizing instead of basically steam, would it be fair to say that it's closer to a refrigerant?
It's closer to a refrigerant. It's
Okay.
called as ORC, organic Rankine cycle. The core of it is organic fluids, and organic fluids are majority refrigerant fluids.
Okay. For example, any one that you use or like something similar?
R245 FA is used. Pentene is used. In Indian condition, isopentene is also used.
Butane. So
Butane is one good one.
Okay.
Butane and isobutane can enable you to recover from 60 degrees also, lower than water boiling temperature.
Okay, so when we are talking about heat, we are mainly talking about T delta. Basically,
Right.
how cold is your cold source and how hot is your hot source.
Yes.
Now, in steam systems, we are talking hundreds of degrees Celsius gap. So your fire furnace could be as high as 1600 degrees Celsius, and your cold, we try to make it as close to ambient as possible. And sometimes it consumes water in order to achieve that.
Right.
Now, in your scenario, because it's a closed loop, there is no what you call loss of working mass, so to say. You're not losing steam, you're not losing refrigerant, whatever.
Yes.
It's a closed loop, right?
It's a closed loop cycle.
Okay.
No emissions.
So how close that T delta can be in your systems compared to steam cycles?
So the effectiveness of the heat exchangers which we use is the pinch point is 5 degrees. We have reached to 5 degrees as well. So that's possible for us to have.
Meaning
the
your
delta of
system
5.
can start with very mild heat difference.
As near as possible. It is possible. We have tested this. We have reached 3 degrees as well. But for it to go to 3 degrees, you need to have it ideally running condition. But the effectiveness of our heat exchanger is lying between 0.8 to 0.9. So that's where it is possible for us to go for pinch of 3 and 5 degrees.
Okay, so that means if I want to generate electricity from solar thermal, you can do that, right?
Yes, and that will be a very beautiful source of heat because it is an independent power producer. You are not utilizing anything. Someone's raw is already coming and you are utilizing it. So independent power production is possible in that case also.
Okay, what about efficiency? What sort of efficiency we are looking
So
at?
the efficiency for this, since it is a low temperature heat sources, the efficiency lies from 10% to 30%.
Okay, now let's talk about the most important aspect. What about the cost?
The cost right now is a pretty higher since the technology is not that in that format. The industry is not that nurtured. But yes, pretty soon people will adapt to this and the ROI will be very scalable once people start to understand the importance of it. That you are not only getting electricity, but you are also getting something called as heat load or cooling load is also possible. That's where we can become the cycle integrator. Rather than selling the machine, we sell the process. We help the plant increase their efficiency, and that's where the ROI could sit around 3 years, lesser than 3 years.
Okay. Now,
And we are much cheaper than other European countries as well, because we develop this in India, we manufacture this, we test this in India as well.
so it is truly made in India, not just
Truly
like
made in
claimed.
India.
You are actually making it in India. Okay.
Yes.
One important question is, what are your current client list? Who are the clients of this sort of technology right now?
So we are targeting steel industry
Uh-huh.
as of now.
Uh-huh.
And steel industry is somewhere they have the immense capital as well for this to deploy and understand the core things. And there are regulatory mechanisms for them to be implemented since the regulation is there higher. So right now we are targeting steam audience.
Okay.
Steel audience.
Okay. What sort of product you are planning to manufacture? As in, like, are you planning to make a standard shipping unit, or like you want to make bespoke component for each company? What is your aim?
So basically, we will try to sell the standard ones only, and we have developed it in stack-based format only. Right now, we have developed 25 kilowatt unit. We'll be pretty soon developing 50 and 100 kilowatt, and these all will be stackables. If you need 100 kilowatt, we'll be deploying 25 kilowatt 4 unit. And if you are running on partial load condition, let's say 4 furnaces, and right now you are running on 2 furnaces, then it is possible enough for you to only utilize 2 machines rather than 4 all. And you will hit up that efficiency margin. Because heat exchanger, ultimately, you have to give that surface area. So rather than building a 100 kilowatt, you stack up 25 kilowatts.
Okay, do you think would it be viable to use, like, let's say data center heat or things of this nature, or would the temperature delta would be too close to not being very efficient?
There are research papers, there are practical use cases of this. ORC has been already used in data center. There are Australian companies who have developed this and they are being used.
Okay, okay. So it can be done where instead of just wasting that heat by air conditioner, you can get the cooling while getting electricity.
Exactly.
So not only you are getting the cold part, but you are also getting electricity. Okay. And again, you are still using the same thing, a refrigerant.
Yes.
Okay, so talk about the core components of this machine. How many core components? Like I see this diagram here. So you have heat exchanger, and turbine, and then you have feed pump. So talk about this sort of cycle.
So in this cycle, you have majority the heart of this system is going to be the turbine, since it is going to generate the electricity. That is what we built. We integrate the cycle. We select the component accordingly. There are plate heat exchangers used for this. Since efficiency is higher, we use dimple plate heat exchangers. We also use mag drive pump for this. Since these are sealless, you can also go into ATEX zone. And you again need alternators for this. We develop our own alternator. These are
in-house?
Yeah. These are high frequency alternators.
Okay. What sort of frequency we are talking about here?
3000 to 5000.
Wow, that's a very high RPM machine, right?
Yeah.
Okay.
That's why it is very small as well. It puts 25 kilowatt unit. The turbine itself puts it on your hand.
Wow. So that means it's a shippable item. Like you can ship it on a shipping container, right?
Yes.
Okay. So that means deployment would be easy as long as you have a truck route and you can drop a shipping container at customer's location. You should be able to just plug and play this sort of device. Right. Okay. What are your plans now going forward?
So we are deploying this and we'll be launching in March. Across aluminum furnace. Since people want to know how the system is running, they can also visit our facility and understand how the technology is, and we'll be deploying this for the steel industry in the coming days.
Okay. So have you gotten any interest from independent players here? Like what sort of interest you have generated here?
So there are a couple of interests where they use blast furnaces systems, arc-based furnaces systems also. These are majority from steel industry and manufacturing industries only.
So main benefit is that you can recover this heat that there was no use for it. You can recover electricity out of it, which is far more desirable and actually useful, directly useful. And again, it can even become a direct source of electricity if you are using, let's say, concentrated solar or things of this nature,
right?
Which again, places that do not have silicon technology and silicon solar cells and inverters, it would be a very priceless asset. So when we are talking about the technology, like the core essence of the technology is very simple, right? It's not what you call a silicon level where you have to slice silicon. So everything is very in-house. You are doing it in India. Everything is basically trusted for ourselves. Like we can manufacture it from start to finish, right?
Yes.
Okay. Tell our audience how can they reach you and your company.
So if you want to reach us, you can go on HrimTronEnergy.com. HrimTron, HRIMTRON energy. HrimTron energy stands for Rim is coming from the Sanskrit word power of electrons, and you can contact us there as well. Our details are mentioned on the website. Our stage is also mentioned, and if you want to partner us for the pilots coming out there, please feel free to contact us.
Okay, so this was a very unique tool that allows us to utilize low T delta heat sources, which again, we have more than enough of it. And even if we can recover only 10 to 20% of it in electricity, that would be a significant boon to our industry. So I hope all the best to you, and I'm very proud for that you are making something awesome like this in India, in house. I'm very happy about that, and I wish you all the best.
Thank you so much, Vibhav. Nice to meet you.